Now, there are a few special limits that you have to know for your exam. And I'm not going to prove them to you because you will have a multiple choice exam, so you'll not be required to prove them. But for your sake, you can always look them up and have fun looking at the proof of these limits. The one that I would just mention is the limit of 1 plus 1 over x all to the x as x approaches infinity. That is equal to e. I'm just telling you that one for you to keep it in mind. But on many papers, what I have seen is a lot of mention of these limits. The limit of sine theta over theta as x approaches 0. Now, at first glance, it may seem as though this limit does not exist because sine theta over theta, direct substitution, we get 0 over 0, and so the limit does not exist. But really and truly, the limit does exist. And to prove this, we're going to look at the graph of sine theta over theta. So here's the graph of sine theta over theta. And if we approach 0 from the right-hand side, we see that f of x is getting closer and closer to 1. If we approach 0 from the left-hand side, we see that f of x is getting closer and closer to 1. And so for that reason, we can say that in truth and in fact, the limit of sine theta over theta as x approaches 0 is equal to 1. Now, another limit that we'd want to pay special attention to is the limit of cos theta minus 1 all over theta as theta approaches 0. And again, at first glance, we're seeing here that we're dividing by 0 if we do a direct substitution. But again, this is another special limit because the limit actually does exist. And as I said before, we're not going to be proving this algebraically, but I will show you from the graph exactly why we say that the limit does exist. Right here, we can see the graph of, or the curve for cos x minus 1 all over x. And we want to find the limit as x approaches 0. So from the left, as x approaches 0, we are getting closer and closer to 0. Let's see if we get the same thing when we approach 0 from the right. So we are approaching 0 and f of x is approaching 0. So for this reason, we can say that the limit of cos x minus 1 all over x as x approaches 0 is equal to 0. So now that we've come to see in truth and in fact that the limit of sine theta over theta as theta approaches 0 is equal to 1, and the limit of cos theta minus 1 all over theta as theta approaches 0 is 0, let's have some fun with it. Suppose we were to say that you needed to find the limit of sine 6 theta over theta as theta approaches 0. No. The only thing that we know is that if we had sine theta over theta, then the limit of this as theta approaches 0 would be equal to 1. But here, this is different from this. So we can't come to that same conclusion. So what do we do then? We need to just manipulate the situation here and say, okay, whatever is right here, I need to get it right here without actually changing the value of the function itself. So what I'm going to do is that I'm going to take this function sine 6 theta over theta and multiply it by 1 in a special way. How am I going to do that? I'm going to say that I'm not just finding the limit of sine 6 theta over theta, but I'm finding the limit of sine 6 theta over theta times 6 over 6, which is 1, as theta approaches 0. So what does that give me? That is saying that I am finding the limit of 6 sine 6 theta over 6 theta as theta approaches 0. So let's make some space right here. And let's take it from right here now. So we have that the limit, we're looking for the limit of this function right here. This is what we're finding the limit for. Now, since 6 theta here and 6 theta here are the same, then it's like we're saying, okay, let 6 theta be equal to a. So that would be implying that we are finding the limit of 6 sine a over a. So since we have sine a over a, then the limit of that as x approaches 0 is 1. So in other words, we're saying that by laws of limits, this would give us 6 times the limit of sine 6 theta over 6 theta as theta approaches 0. And all of this, all that we did a while ago, was just to get what? All we wanted to do was to get whatever term was here to be here too. Because we needed that in order to exploit or make use of the fact that the limit of this function right here, sine theta over theta, as theta approaches 0, is 1. So now we know that the limit, this limit here, is equal to what? 1. And all we do know is that since this is equal to 1 and this is 6 times 1, then the answer would be 6. In other words, what this is saying in conclusion is that the limit of sine 6 theta over theta as theta approaches 0 is equal to 6. Now let's see how we carry out a similar manipulation for the other special limit that we made reference to. So we want to find the limit of cos 4 theta minus 1 all over 2 theta as theta approaches 0. Now keep in mind that the special fact that we want to take advantage of, or that we want to exploit, is that the limit of cos theta minus 1 all over theta as theta approaches 0 is equal to 0. That is what we want to take advantage of. So let's do that. To take advantage of that, we have to ensure that this term and this term are the same. So how do you do that? Again, in similar manner as we did before with the other special limit, we multiply by 1. So let's multiply by 1. So we have the limit of cos 4 theta minus 1 all over 2 theta. I'm going to multiply that now by 2 over 2. And theta is approaching 0. So what do we get? We get that we're looking for the limit of cos 4 theta minus 2 cos 4 theta minus 2 all over 4 theta as theta approaches 0. So now we have what we want. But there's a 2 here and a 2 here. So what are we going to do there? All we need to do is just factor them out. So we'll end up with 2 times the limit of cos 4 theta minus 1 all over 4 theta as theta approaches 0. So again, let's make some more space. And we're going to come up here. And so we know that since this and this are the same terms, then all we need to do is just say that the limit of cos 4 theta minus 1 all over 4 theta as theta approaches 0 would be equal to what? 0. And that would be 2 times 0, which would be equal to 0. So, in other words, all we're saying is that the limit of cos 4 theta minus 1 all over 2 theta as theta approaches 0 is equal to 0 also. So we just use a similar principle for any other version of these special limits that they give us, so that we can actually find the limit, because it really does exist. And keep in mind that the limit, since it's a multiple choice exam and they could always ask you this, of 1 plus 1 over x to the x as x approaches infinity is equal to e.